Hey everyone, this is Steve. Today let's go through LeetCode problem 1772, sort features by popularity. I think this is a problem that came up in one of the recent contests. Pretty straightforward, but still it's fun that I used a combination of, anyone could use a combination of different data structures. So first let's take a look at the problem description. You are given a string array features where features I is a single word. You see features, this is features. Features I, cooler, lock, touched. All of these are single word that represents the name of a feature. Okay, all of these three are features. Of the latest product that you are working on, you have made a survey where users have reported which features they like. You are given a string array responses, where each responses I is a string containing space-separated words. Okay, space is the delimiter. I, like, cooler, cooler. So a total of 4 words. It mentions cooler twice, right? So the popularity, so here comes the definition of popularity. The popularity of a feature is the number of responses that contain the feature. You want to sort the features in non-increasing order by their popularity. If two features have the same popularity, order them by their original index in features. Say, if cooler and lock, they have the same popularity supposed, and then we'll arrange cooler appear first in the result because cooler has a lower original index than lock, right? It's 0 and it's 1. All right, that's what it means. Order them by their original index in features. Notice that one response could contain the same feature multiple times. Notice that one response could contain the same feature multiple times, like cooler, cooler, right? The same response contains the one feature twice. That's what it was referring to. This feature is only counted once in its popularity. All right, so here's something we need to pay attention to. Although this word, this feature appears twice, more than once in this response, you'll be counted only once. All right, so only once is counted. So it's asking us to return the features in sorted order. Let's see. So appearances of cooler. So cooler is the first feature that it appears once, right? Cooler appears only once. There are 3 responses here, 1, 2, and 3. But cooler appears only in one response, although it appears twice, we count only once, right? I like cooler, cooler, cooler appears once in one response. Cooler appears twice, but it's in one response. All right. So then appearances lock. Lock is only once. It's in the second response, right? Locker is not equal to lock. And then touch. Touch appears twice. So touch here and touch here. So touch appears in 2 responses. That's why touch is 2. Since cooler and lock both had one appearance, cooler comes first, then lock. So that's why the result cooler, lock, and the first one is touch because touch has 2 appearances in 2 different responses. All right, this is the problem, this is the context, very straightforward. So the idea that came to me is that we can just follow the description or definition of the popularity and what it's asking us for. We can just follow this as a very intuitive solution. We can define a class, for example, called node. Let's see. I'll just call it class node. You can call it whatever you want. We'll have 3 fields. One is index, which is its original index, because just in case there's a tie of popularity, we'll use its original index to sort it. And the second is popularity. We can call it frequency. And the third is just the feature. We can call it word, right? So what we can do is that we can build a priority queue or a max heap. And how do we sort the max heap or the priority queue is that we use 2 sorting rules. One is that we'll use priority based first. If there's a tie in terms of priority, we'll use the original index. After that, we'll just keep pulling everything out of the priority queue and assert them and put them into this string array result, and then return. That's it. So how do we form this node? We can use hash maps. We can use 2 hash maps to help us achieve how to build, to go through all of these nodes, to build all of these node objects and put them into a priority queue. The first hash map could simply be, we can simply turn this features array into a hash map so that we can have easy access based on the feature to its original index. And then the second hash map, we can just go through this responses array. And remember, we need to separate each of the response from these responses into space separated strings, and then we'll count only one feature out of this space separated strings from one response as once, and then add all of the popularities into the second hash map. With the second hash map, along with the first one, we can just build the priority queue and insert all of these node objects into this priority queue. In the end, we'll just pull everything out of the priority queue. I hope that makes sense. If it doesn't, or if it's not super clear, just bear with me. Let's just put the idea into the actual code. Hopefully everything will be clear. So first, I'll have a map. As I said, the first map is very straightforward. It's just going to give us easy and quick access to the index of the features, right? Because we need it. Integer. So the key of the hash map is the feature itself, and the integer, the value of that first hash map, is just going to be the index. Map new hash map, and then we'll just go through this. I equals 0, I smaller than. Of course, there are multiple other different approaches to solve this problem. I'm just talking about the one that's most intuitive and the one that occurred to me. So feel free to comment down below if you have any other ideas on how you want to optimize this. I'll be happy to take a look and see how you guys do this. Features length I++, and then map put features I and I. Alright, this is the first one. And then the second one, we need another hash map, is basically to see. So we need a second hash map. It basically tells us what's the popularity of each feature, right? So the key is still the feature, but the value is still an integer type, but the value is going to represent the popularity, right, of each feature. I'll call it count map, make it more descriptive. Hash map. And then what's next? We'll go through all of the features now. We'll go through all of the response now. Responses. Alright, so we'll just go through every single response. Since it's talking about the feature is only counted once in its popularity, just in case that one response could contain the same feature multiple times. Although it's multiple times, we'll count it only once because it's one response. So how do you deduplicate this, right? So we'll just use a hash set. Every element in the hash set is guaranteed to be unique, right? So we can use a hash set to do the job. So arrays as list, and then we'll just response split based on this empty string, right? Space. Oh no, not empty string. It's called space. Yes. So we just split the response into every single word, and then we assign them into a hash set to deduplicate. That's what this does. With this, we'll just go through every single word in this response strings. Right. So now what we will do, since this set is containing all of the potential popularity of every single feature, right? So we'll just go through this map. So if map contains key, which is string, and then what we'll do, we'll just update this one, right? We'll update count map put string count map put. What are we going to put? We'll put this one. This is the feature. It could get all default because this feature might exist or it might not exist. If it's not exist, we'll just assign 0 to it. Otherwise, we'll just increment it by 1. With this step, we have built this count map, which gives us all of the features popularity, right? So after this is done, then we can start building our priority queue. Priority queue. Yeah, I think that's correct. Node. Of its type is node. I'll just call it heap. New. Let me copy this. New priority queue. And so here, how do we sort this priority queue? So first, we'll check if its frequency is not equal to B's frequency. How come this one is not honored? Maybe I need to make it public. It should autocomplete, right? So if frequency, like popularity, is not equal, we'll just use the more popular. So we'll use B frequency minus A frequency. However, the other equal, we'll use its original index. We'll use A's index minus B's index, right? So that we use the first index, the feature that has a smaller index that will be appearing in the result list first. So, all right, now we can go through this feature count map key set. Now we'll just build the node objects into this heap offer. New node. First is the index. So how do we get the index? We'll get map get feature. This one will give us the index, and then frequency we'll get it from count map get feature. And then the word is just feature itself, right? So for count map, then the word is just feature itself. So for count map, I think we need get all default, because it's possible that like there's a feature that's not popular at all. It doesn't appear in any of the responses after we parsing the string, right? So get all default 0. Otherwise, if we get a very unpopular feature, we might not have any hits, right? So otherwise we will throw exceptions. Now, okay, now we can initialize the result new string. The size of the result is just a heap size, right? And then we'll just pop everything off. Heap is empty. While it's not empty, we'll just pop everything off. Result, oops, I need one more index. Result, assign this heap poll, and heap poll, it's going to give us a node. So after we do heap poll, we'll just get a word, right? And then in the end, we'll just return result. That's it. Hopefully it can work. Let me hit run code to see any errors. Cannot find symbol in Node Java. Alright, that's why. I can tell something is not correct here. Alright, I think I'm missing the angle brackets to initialize it. Okay, now that one passed, so I got a new one. No constructor. Alright, I do need a constructor. Public node. So the first one is int index. The second one is int frequency. The third one is string word. I thought there's a default constructor, so I'm mistaken. This index gives it to index, and this frequency. I like autocomplete of LeetCode. That's so awesome. I don't know how to write code without IDEs. Sad. Word. Alright, so this is the constructor. Let me hit run code one more time. Alright, accepted. Now let me hit submit. Alright, run answered. That's unfortunate. So the my output is this, and the expected output is this. So I'm missing C here. What the heck? Input is, oh, because, yeah, I'm still missing this. So you see C here, it's not popular at all. It doesn't appear in any one of these responses, but still we need to put C here because it's one of the features, although it comes last, right? So where am I missing this C? That is because of what? Let me take a look how to debug this. Let me take a look how we can debug this. So first I build the map, and then this is just an index map, and this is the count map, count map, and count map here. And then I initialized a heap object, and then I go through, oh, I don't think I should go through the count map because count map is incomplete, right? I think I should go through this map. This map will give me all of the features. Alright, now let me just copy this one and rerun this one. It's going to be fun. Oops. Rerun this one. See if it can be accepted. Alright, it's accepted. Yeah, I think the issue is this. Let me see if it can be accepted. Alright, it's truly accepted. So yeah, so this one I should go through this map because this is an index map. It's basically a mapping of the entire features so that I don't miss any features, any unpopular features out. Alright, so this is my response to this problem. What's it called? It's called sort features by popularity. And yeah, anyway, pretty straightforward and simple as long as we follow what the problem is asking us to do. Come up with reasonable data structures, priority queue, a hash map, or even an customized class. This is my response. So of course there are many other responses. Feel free to comment down below in the description and let me know how you guys approach this problem. Yeah, but that's it for this one from my side. I hope you guys enjoyed this video. If that is the case, please do me a favor and hit the like button. That's going to help a lot with the YouTube algorithm. And also please don't forget to subscribe to my channel, as I have accumulated quite a lot of different LeetCode tutorials or data structures, DFS, BFS, DP, whatever you name it. And also quite a lot of AWS computing, AWS cloud computing certification exams, how I passed those and prepared for them. So feel free to check them out. So hopefully I'll just see you guys in just a few short seconds in my other videos. See you guys soon.